In this chapter, we are going to talk about multithreading. So first of all, what is multithreading? Multithreading is a Java feature that allows concurrent execution of two or more parts of a program for making optimal use of the available resources, especially when your computer has multiple CPUs. Multithreading enables you to handle multiple activities concurrently in the same program. So first of all, a thread is a lightweight subprocess, the smallest unit of processing, and it's executed inside the process. So it is extremely crucial that operating system may have several processes and every single process may have several threads. So threads are associated with a given process. Each of the threads can run in parallel and there is context switching between the threads. There can be multiple processes inside the operating system and one process can have multiple threads. So the operating system has several processes and every single process may have several threads. Okay, so what is the advantage of multithreading? Every single process may have several threads. This is what we have been talking about. In this case, the first thread has just a single thread and the second process has three distinct threads. So the advantages of multithreading is that first of all, it allows multiple operations at once as they are not dependent on each other, thus not blocking the user. Then it saves time as multiple operations are possible. And finally, the threads are independent, thus making the functionality better. So for example, as far as the single-threaded application is concerned, we have the first for loop and all the other operations have to wait for the first operation to finish. After we finish with the first loop, then the application can do the second loop, and after it is finished, then the application do the third loop. This is the case when it is a single-threaded application. If we have multiple threads, for example 3 distinct threads, then every single thread can do a given operation. In this case, the first thread is going to do the first loop, the second thread is going to do the second loop, and the third thread is going to do the third loop. So as you can see, it is the main advantage of multithreading that we can do several operations concurrently. Of course, there are some disadvantages as well. First of all, it is extremely hard to debug a multi-threaded application. If you have, for example, a null pointer exception or something like this, it is extremely hard to debug the given errors. Then, multi-threading applications are quite hard to develop. It is quite complex to handle and understand multi-threaded applications. And the main disadvantage as far as multi-threading is concerned, that it is quite expensive to deal with multiple threads because the central processing unit, so the CPU, has to track what thread is doing what operation. So this is why using too many threads is going to make the application slower. So there is some trade-off between the number of threads and the speed of the application. Using more than just a single thread is a good idea, but using too many threads may result in an extremely slow application. Okay, let's talk about the life cycle of a thread. First of all, if we instantiate a new thread, then the thread is going to be in the new state. With the help of the start method, we are able to start a given thread, and that's when the thread will be in the runnable state. Thread scheduler of the Java virtual machine runs the thread as soon as the processor becomes available. With the help of the run method, the thread is going to be in the running state, and the thread terminates as soon as the run method ends. So this is the terminated state. So a given thread may be in a new state, runnable state, running state, terminated state, and the last state we have to consider is when we call the sleep method or the wait method, and this is when the thread is in a blocked state. So whenever a thread goes to blocked state, it will run again when it returns to runnable state. If the sleep method is called, the thread will go to sleeping state, it changes into runnable state again after sleep time is over. And if the wait method is called, the thread will go to the waiting state, it goes to runnable state after it gets notification through the notify or notify all methods. We are going to talk a lot about these methods in the coming lectures, and it's going to be clear what's crucial, that whenever we instantiate a new thread, then it's going to be in the new state. when we start the given thread, and this is the runnable state. Whenever we call the run method, the thread is going to be in the running state. We can call the sleep and wait methods, and because of these methods, the thread is going to be in a blocked state, and whenever the thread has done with its tasks, then it is going to be terminated. There are two ways to create a given thread. We can implement the runnable interface, so a given class may implement the runnable interface, and then we can instantiate a new thread, and we have to define that given runnable interface. So this is why we can instantiate a thread example, which is a class, but this class implements the runnable interface. The runnable interface has the run method, which means that the given thread we have instantiated is going to do the operations we have defined within the run method. And as you can see, if we call object.start, this is how we can make sure that the thread is going to do the operations we have defined in the run method. Okay, another way is to use the thread class. So we can create a thread example class, and it can extend the thread class. Again, we have to override the run method, and we can instantiate the thread example like this. And because this thread example extends the thread, we can start it with the help of the start method. So there are two ways to create a thread: implementing the runnable interface or extending the thread class. In the coming lectures, we are going to talk about how to create a thread and how to use multi-threaded applications. Thanks for watching. In this lecture, we are going to take a look at the concrete implementation of threads. So first of all, I'm going to create a new class. So new class, for example, thread example. And this is what we have been talking about in a theoretical section, that there are two ways to create a thread. First of all, we can make sure that the given class implements the runnable interface. So we have to make sure that it implements the runnable, and because of this runnable interface, we have no other option but to override the run method. And whenever the thread is started, this is the method that's going to be called. So I'm going to print out that thread number plus thread current thread dot get id is running. So this is how we can get the ID associated with the current thread. Thread current thread get ID. Okay, so let's save it, and in the application.java we can create a thread t1 new thread, and here we can instantiate a new thread example. So this thread is waiting for a runnable interface, as you can see, and because the thread example implements the runnable interface, this is why we can do something like this. And what do we have to do? This is what we have been talking about as well, that with the help of the start method, we are able to start the given thread. So it causes this thread to begin execution. The Java virtual machine calls the run method of this thread. So whenever we call this start method on the thread, then the thread example run method is going to be called. So if I save it and run it, then thread number 11 is running. This is the ID of the given thread. Okay, we are able to create a for loop. So integer number of threads is equals to 6, for example, and for integer I is equals to 0, I is less than the number of threads, I plus plus. We instantiate a thread, so thread t is equals to a new thread. We have to instantiate a new thread example, so like this, and we have to start the given thread. So what's going to happen? It's quite straightforward. We create 6 threads and we start them, which means that every single thread's run method is going to be executed. So if I save and run it, as you can see, thread with ID 11 is running, then thread with ID 16 is running, then 13, 14, 15, 12. So these are the IDs associated with the given threads. And as you can see, we have managed to create 6 threads because the number of threads is equals to 6. We are able to do it in another way. Instead of implementing the runnable interface, we can make sure that this thread example extends the thread class. And if this thread example is a thread, then we can use something like instead of a thread, we can use the thread example directly. So a thread is equals to a new thread example, and as you can see, it is going to work just fine. So if I save it and run it, then it is going to be exactly the same. So there are two possible ways to create a thread in Java. A given class may extend the thread, or it may implement the runnable interface. As far as I am concerned, I am a huge fan of implementing the runnable interface. Why? Because a given class may implement several interfaces, but it can only extend a single class. So if this thread example extends the thread class, then this class is not able to extend any other class, which is not the best solution possible if we want to use inheritance. If we use implements the runnable interface, a given class may implement as many interfaces as we want, and it may extend another class as well. So this is why it is a bit better solution to use the runnable interface as far as I am concerned. Thanks for watching. In this lecture, we are going to demonstrate the difference between sequential execution and multi-threaded execution. So I'm going to create a runner1 class, and I'm going to create the runner2 class, and both of these classes will have the public void do operation method. And within this do operation method, I'm going to create a for loop integer I is 0, I is less than 10, I++, and here I'm going to print out that runner1 with integer value plus the I. So just for demonstration purposes, we are going to do some operations as far as the first runner is concerned, and we are going to do approximately the same as far as the second runner is concerned. Of course, it is the runner 2. So both of the runners will have a do operation method with a for loop, and it is going to print out runner2 with integer value and the I value. So as far as sequential execution is concerned, it means that the tasks are executed one after the other. So I'm going to instantiate runner1. Runner1 is a new runner1. I'm going to instantiate the runner2, which is a runner2. And then I'm going to call the do operation as far as the runner1 is concerned, and then I'm going to call the do operation as far as runner 2 is concerned. And because we don't use multi-threading, what's going to happen? Java is going to instantiate the first runner, then Java is going to instantiate the second runner, then Java is going to run the do operation method as far as runner 1 is concerned, and after it is done, then Java is going to call the do operation method of the second runner. So if I save and run it, runner1 with integer value 0, 1, 2, 3, 4, 5, 6 up to 9. These are the operations as far as the first runner is concerned, and these are the operations as far as the second runner is concerned. So this is called sequential execution, where the tasks are executed one after the other. Is it possible to do both operations at the same time, so in a concurrent manner? Of course, this is what we have been talking about, that we have to implement the runnable interface, and the runnable interface has the run method. So instead of the do operation method, we are going to use the run method, and we do the same for the second runner. So it implements the runnable interface. Of course, we have to override the unimplemented run method. We create the for loop as usual, and I'm going to get rid of the do operation. So because runner2 implements the runnable interface and runner1 implements the runnable interface, this is why we can assign a distinct thread for runner1 and runner2. So what does it mean? That we are able to run both the operations in a concurrent manner. So if I use thread t1 is a new thread, and here we instantiate runner1, something like this, and we do approximately the same with t2 new thread with new runner2, then we are able to start the given thread with the help of the start method. This is what we have been talking about, that if we start the given thread, then Java is going to call the run method automatically. So if we do the same for t2.start, instead of the sequential execution, we are going to end up with a concurrent execution. So I'm going to get rid of this. If I save it and run it, then as you can see, the order is not that straightforward. Okay, we have the second runner, but after that we have the first runner. So basically it means that both the operations are running at the same time. If we want to make sure that it is working fine, I'm going to do something like this, that after every iteration, we call the thread.sleep method for 100 milliseconds. Okay, first of all, we have to use a try-catch block, but if you check the sleep method, it causes the current executing thread to sleep, so temporarily cease execution for the specified number of milliseconds. So we are going to wait for 100 milliseconds after every single iteration. And I would like to do the same for the second runner as well. So something like this. And if we run the application like that, then as you can see, runner 1, runner 2, then runner 2, runner 1, runner 2, runner 1. So Java is going to execute both threads concurrently, which means that both the operations are being executed at the same time. Okay, so this is why we sleep for 100 milliseconds to be able to see the demonstration. As you can see, value 0, value 0, value 1, value 1, 2 and 2, because the first thread is printing out 0, then the second thread is printing out 0, then the first thread printing out 1, then the second thread is printing out 1. So Java is going to run the operations in a concurrent manner because we assigned distinct threads to distinct operations. What's crucial that we are able to say that t1.join with the help of the join method. Of course, we have to surround with try catch. I'm going to throw the given exception, interrupted exception, as you can see. So what does it mean? Why is it good to use the join method? As far as the documentation is concerned, as you can see, waits for this thread to die. So if we call join, then Java is not going to execute the t2.start until the t1.start has been finished. So if I save and run it, then it is going to be very, very similar to a sequential execution. First, Java is going to start the first thread, but because we called t1.join, then Java is going to be notified that, okay, let's wait for the first thread to finish. And after it's finished with the task, then Java is going to start the second thread, and as you can see, the second thread related operations are being executed as well. So what's crucial that with the help of threads and with the help of the runnable interfaces, we are able to assign a given operation to a given thread. And if we do not call the join method, then let's save and run it again. We can run multiple operations at the same time. Okay, so in the next lectures, we are going to talk a lot more about multithreading and synchronization. What's crucial that it is an extremely powerful feature of Java that we can handle multiple threads. Thanks for watching. In the coming lectures, we are going to talk about synchronization. So first of all, what is synchronization? In a multi-threaded environment, multiple threads created from the same object share object variables, and this can lead to data inconsistency when the threads are reading or updating the given shared data. The reason for data inconsistency is because updating any field value is not an atomic process. It requires 3 steps. First, to read the current value, second, to do the necessary operations in order to get the updated value, and finally to assign the updated value to the field reference. So this is why if we have multiple threads manipulating the same data, there may be data inconsistencies. Let's consider that we have 2 threads, thread 1 and thread 2. If we want to increment the value of a given integer, then thread 1 is going to read the current value in this case the current value is 0, then it is going to increase the value, so increment the value by 1, and then it is going to set the counter's new value to be 1. But because we have two threads, while these operations are happening, the second thread may get the value of the given counter, which is 0 at the beginning, because the first thread has to deal with these 3 steps in order to update the value. So it may happen then the second thread get the value of the counter before the first thread updates it. So the second thread is going to do the same, read current value, so with value 0, it increments the value by 1 and then set the counter's new value to 1. And this is why inconsistency may happen, because most of the operations are not atomic. The solution is that we have to make sure by some synchronization that only one thread can access the resource at a given time. Thread safety in Java is the process to make our program safe to use in multi-threaded environment. Synchronization is the easiest and most widely used tool for thread safety in Java. So as you can see, in this case we have 2 threads, and somehow we have to make sure that the given data is synchronized. Let's talk about a Java monitor. A monitor is a mechanism to control concurrent access to an object. This prevents multiple threads accessing the monitored or the synchronized section at the same time. One thread will start and the monitor will prevent the other thread from accessing the region before the previous one finishes, which means that only one thread can hold the lock on the monitor at a given time. Okay, so we have several threads. So threads enter the acquire lock or the so-called entry set. Then the lock is acquired by the thread. So in this case, the green thread is the active thread. Then the thread goes to the waiting state if you call the wait method on the object, otherwise it releases the lock and exits. If you call notify or notify all, it wakes up the thread or all the threads. We are going to talk a lot about these methods and it's going to be clear. And now the thread is available to acquire the lock. After completion of the task, thread releases the lock and exits the monitor state. So basically the monitor is going to make sure that processes are going to be synchronized. So no 2 threads can update the same variable at the same time. Otherwise, we would end up with data inconsistency. And this is why we have to use the synchronized keyword. Synchronized in Java is an implementation of the monitor concept, and Java Virtual Machine guarantees that synchronized code will be executed by only one thread at a given time. Java synchronized keyword is used to create this, and internally it uses locks on the object or the class to make sure that only one thread is executing the synchronized code at a given time. There are different ways in Java to create synchronized code. With the help of synchronized method, we have to use the synchronized keyword void method name, and it means that the method is synchronized. So no 2 threads can manipulate the method at the same time. We can use static synchronization when the method is static, or we can use synchronized blocks. So as you can see, synchronized without a method name, it is called a synchronized block. So with the help of the synchronized keyword, we can make sure that the operations are going to be thread safe. So there's not going to be any data inconsistency. In the next lecture, we are going to talk a lot about the synchronized keyword, about the wait method, notify method, and all the synchronization related issues. Thanks for watching. In this lecture, we are going to talk about synchronization. So let's consider a situation that we have a private integer counter. We set the value to be 0 at the beginning. We make it static because we would like to manipulate this integer counter variable from a static method. And we are going to have a public static void increment method that's going to increment the value of the counter itself. Sorry for that, we have to use this. Okay, and here in the main method we are going to use 2 threads. So thread T1 is a new thread, and we are going to use an anonymous inner class. So we instantiate the interface, and here we have to define the run method as usual. So something like this. Okay, and here I'm going to create a for loop. Integer I is 0, I is less than 1000, and I++. And we are going to call the increment method. So this thread, this T1, is going to call the increment method 1000 times. And we are going to do the same with another thread. So the T2 is going to make 1000 iterations as well, and it is going to call the increment method as well. So we are going to start T1, we are going to start T2, and we are wait for them to finish. So T2 dot join. Okay, of course we have to use a try catch block. So surround with try catch. I'm going to use it like this, and finally we are going to print out the value of the counter. So counter is equals to the counter. You may pose the question that why is it crucial to call the join method, because otherwise Java is going to start the first thread, the second thread, and immediately it is going to print out the value of the counter before the threads are finishing with their operations. So this is why it is crucial that we would like to wait for the threads to finish with their incrementation processes. Okay, so if I run the application, then the result is going to be rather inconsistent. The first thread increments the value of the counter 1000 times, the second thread increments the counter 1000 times, so we should get 2000, and as you can see, we don't get 2000 at all. Okay, sometimes we get, but most of the cases it is not working fine. And this is exactly what we have been talking about in the theoretical section, that incrementation is not an atomic process. It requires 3 steps. First of all, the first thread is going to read the counter variable, then it is going to increment the value, and finally it is going to update the value of the counter. So there are 3 main steps, but within these 3 steps, the second thread may get the value of the counter before the first thread updated. So this is why there may be inconsistencies. So what could be the solution? We should use synchronization. So we should make sure that while a given thread is manipulating the counter, the other threads have to wait for it to finish before starting to manipulate the given variable. So this is exactly why we have to use synchronized keyword. So if we use public synchronized static void increment, what's going to happen? That whenever the first thread calls the increment, then the second thread has to wait for the thread to finish with this method, and vice versa. If the second thread is calling the increment, then the first thread has to wait for the second thread to finish with this operation. So if I save and run it, as you can see, with the help of the synchronized keyword, we are able to solve the problem, and it's going to be consistent. So the value is going to be 2000 because the first thread increments the value 1000 times and the second thread increments the value for 1000 times. What's crucial that it is called static synchronization because it is a static method. So in short, if you synchronize on a static method, you will synchronize on the class, so on the object, and not on an instance. That means while execution of a static method, the whole class is blocked. So other static synchronized methods are also blocked if they are also synchronized. So what does it mean exactly? That if I have a totally independent public static synchronized method, for example, do operation, and it is going to, I'm not sure, solve, for example, solving a differential equation, which means that it is totally independent of this operation, then because we use the synchronized on a static method, then if a given thread is calling the increment method, then other threads have to wait in order to run the do operation method, although they are totally independent of each other. Because synchronized keyword has something to do with the class. If a given thread enters a synchronized static method, then Java is going to notify all the other threads that, okay, let's wait for that given thread to finish. No matter that we would like to call a totally independent method, this is how static synchronization works. So this is how we can use the synchronized keyword. Thanks for watching. In the previous lecture, we have been talking about that if we use synchronized methods, it is not the best solution possible, because if a given thread is entering a synchronized method, then all the threads must wait in order to execute a different synchronized method, because they are looking on the class itself. So this is why it is not the best solution possible, because in this case, these methods are totally independent of each other. So we should make sure that a given thread may manipulate the increment method and a different thread may call the do operation method without any issue, because they are independent of each other. And this is why synchronized blocks came to be. Okay, so I'm going to create a class just for demonstration purposes, show numbers class, and within the show number class we have a public void print numbers method with an integer n. Here we print out that numbers starting with, and we print out the value of n, and we do a simple for loop. Integer I is equals to 1, I is less than or equals to 5, I++, and here we print out, for example, I times n, and then we sleep for 400 milliseconds, for example. Of course, we have to surround with try-catch block, so I'm going to use a try-catch block with an interrupted exception, as you can see. So this show numbers class has just a single method, the print numbers, and it is going to print the numbers and then sleep for 400 milliseconds. And it is going to print the number times I, and it is going to sleep for 400 milliseconds. Then I'm going to create two classes. The runner1 that extends a thread, because we would like to assign a distinct thread to that given class. We have a show numbers instance like this, and in the constructor it gets a show number. Okay, and we set this dot show numbers is equals to show numbers. We override the run method, and here we are going to call the show numbers dot print numbers, where the n value is equals to 1. So what's going to happen? The runner1 is going to print the numbers 1, 2, 3, 4, 5, and we are going to do another runner2 that's going to be very similar to the runner1, but instead of the n value 1, we are going to use the n value 10. So what does it mean? It is going to print out 10, 20, 30, 40, and 50. So this is the main difference between runner1 and runner2. And if we do not use any synchronization, I guess it's pretty straightforward what's going to happen. But anyways, I'm going to instantiate them as a thread. So T1 is a new runner1. We have the thread T2 is a new runner2. Of course, we have to provide the show numbers class. So let's instantiate the show numbers class like this, and we have to define as the argument for the runner1 and for the runner2. And let's start the given threads. So T1 and T2 dot start. Because we don't use any synchronization, it is going to be the result that 10, 1, 22, 3, 30, 44, 50, and 5. The first solution we can use is what we have discussed in the previous lecture, that we can make this method synchronized, but it is not the best solution possible, because synchronized methods are looking on the class itself, and this is why it is a bit better solution to use a synchronized block. Synchronized block is synchronized, and we can define the so-called mutex. In this case, we define this. So we are going to look on the class itself, but we are not going to make the method synchronized. We just create a synchronized block, and we are going to do the operations. Oh, sorry for that, by the way. I would like to do it here. So the for loop is going to be within the synchronized block as well. So I would like to make sure that the synchronized block will contain the for loop and the thread.sleep operations. And why is it good? Because multiple threads can enter the given print numbers method, but they have to wait for each other to finish because it is a so-called synchronized block. So if we use something like this, I save and run it, then first of all the first thread is going to be executed, and then the second thread is going to be executed. And as you can see, the first thread has already started to run, but the second thread is able to enter the given method because we printed out numbers starting with value 10. Sorry for that, a typo. So the second thread prints out that numbers starting with 10, but the second thread has to wait for the first thread to finish. So what's going to happen? The first thread is going to finish with the for loop and prints out 2, 3, 4, and 5. And after the first thread finished with the synchronized block, then the second thread is able to run the synchronized block on its own. So that's why 10, 20, 30, 40, and 50 are going to be printed out. So the conclusion is synchronized block can be used to perform synchronization on any specific resource of the method. Suppose you have 1,000 lines of code in your method, but you just want to synchronize 5 lines of code. In this case, you can use a synchronized block as we have seen in this given example. So as far as synchronized block is concerned, the lock is acquired on critical block of the code only. So in this case, we don't lock on the method, we just lock on the block itself. So it is the preferred way of synchronization, and performance will be better as compared to synchronized method. Of course, we can use synchronized method with the help of the synchronized keyword as we have discussed in the previous lecture. So we can use something like this, and then there is no need for the synchronized block itself. But it is not the best solution possible because the lock is acquired on the whole method. So performance will be less as compared to synchronized blocks. So the best solution is to use synchronized blocks like this. Thanks for watching. In this lecture, we are going to take a look at a concrete example as far as the wait and notify methods are concerned. With the help of wait and notify all methods, we are able to communicate between threads. So this is what we have been talking about, that with the help of the wait method, the given thread is going to be in the waiting state, which means that it is waiting for other threads to call the notify or notify all method. So if we have a given thread and we call the wait method, it is going to give the log back to the Java virtual machine that's going to assign that to a different thread, which means that the thread will be in the waiting state, and it is going to wait until a different thread calls the notify or the notify all method. So basically, with the help of these methods, we are able to communicate between threads. So let's take a look at a concrete example. We have a class, for example, processor, and in this class we'll have 2 synchronized methods. Public synchronized void, for example, waiting method. Okay, it is one of the methods, and we will have the second method, the so-called synchronized void sleeping method. So it is going to be the sleeping method, and as you can see, both of them are synchronized methods. What does it mean? That if a given thread calls the sleeping method, then all other threads have to wait to call the sleeping method or the waiting method as well, and vice versa. So because both of these methods are synchronized, it is not possible that one thread runs the sleeping method and one thread runs the waiting method in a concurrent manner, because they are synchronized on the same class, which is the processor. So in this case, we are going to get the thread t is equals to the thread.current thread. This is how we can get the current thread. We print out that t.getName, this is how we can get the name of the thread, is releasing the lock and going to wait. Okay, so we call the wait method. Of course, we have to surround it with try catch because there's an interrupted exception. So this wait method is going to cause the current thread to wait until another thread invokes the notify or the notify all methods. Okay, so this waiting method is going to call the wait method on the given thread. and this is where the thread continues when notify is called. So this is why we print out that the t.getName got the object log back and continue its execution. So this waiting method is going to get the current thread and it is going to wait, and then after it is notified, so basically it is woken up, then we print out that the thread got the object log back and continue its execution. As far as the sleeping method is concerned, first we get the thread t thread current thread. We sleep for 3 seconds, so 3000 milliseconds. Of course, we have to surround with try catch because there may be an interrupted exception. And then we call notify. This notify method is going to notify the waiting thread that, okay, you can continue with your execution. And this is when this thread is going to execute with its execution. So after the notify, we print out that a thread which is waiting for lock of this object is notified by the given thread. So this is the waiting method, this is the sleeping method, and the crucial point is that they are synchronized, which means that they are logged on the same class, which is the processor. So this is why it is not possible that the first thread is running this method and the second thread is running this method, because they are synchronized on the same class. Okay, so first of all, I'm going to instantiate a new processor. So processor is a new processor. Then I'm going to create a new thread. So thread T1 is a new thread, and I use an anonymous inner class. So here we can define what's going to happen. We call the processor.waiting method, and I'm going to create another thread for the sleeping method. So T2 is going to run the sleeping method. Okay, so after that I'm going to start the first thread and I'm going to start the second thread as well. So if I run the application, what's going to happen? As you can see, this is when the threads are sleeping for 3000 milliseconds. And what has happened? First of all, the waiting method is called. So first of all, we are going to sleep for 3000 milliseconds. And then we called notify. Notify is going to allow for the second thread to run the waiting method. So this is why the t.getName, which is thread 0, is releasing the lock and going to wait, as you can see. And if we call the wait method, again, this thread is going to run. So we print out that a thread which is waiting for lock of this object is notified by thread 1. And after that, the thread 0 got the object lock back and continue its execution. So this is how we can communicate between threads, because one of the threads is associated with the waiting method and the second thread is associated with the sleeping method. So whenever we call the notify, Java is going to notify the other thread that, okay, you can continue with your execution. If we call the wait method, then again this thread is going to wait and the other thread continue its execution here, and after this thread has finished, of course we return here, and this is what's going to be printed out. So this is how we can communicate between threads with the help of wait and notify. Thanks for watching.